Hi, you're watching my course of comprehensive Arduino lessons. This is a kind of a second video, but as you may have noticed already, the episodes don't have numbers. The reason is simple. You can watch whatever lesson you want, even if you haven't seen the previous ones. My goal is to build lessons in a way that would let viewers watch the course from any part they find interesting. You will see, it will be easy to understand, and if you would like more detailed coverage of some topics, click a link in the description below. Last time I told you about an LED. Today I'll teach you how to control its brightness. I'll show you what is pulse width modulation, how to create an optical illusion with electricity, and spin the LED at a rate of 30,000 RPM. I will draw a Batman peeking from behind the fence. But I'll be drawing not with the marker, but with voltage. So, the LED brightness. We can control it with voltage. See, there is a set of different batteries. This one is a 9 volt. And this one is 3 times less powerful, at 3 volt. I put 2 LEDs in a breadboard. Add 2 similar resistors. Then connect one LED to a 9 volt battery and the other to a 3 volt. The former one lights up brightly, and the latter is about 3 times dimmer. The lower the voltage, the dimmer the LED. Let's replace the battery with a 1.5 volt disk battery. The LED goes completely dim. As you can see, changing the voltage affects the LED brightness. Just what we need, but can our Arduino change the brightness automatically? There's a problem with that. A pin acts as the light switch. It's either on or off. Either it outputs 5 volts or 0. But we can't control brightness with it. I'll just do it with an optical illusion. You're watching this video and aren't really noticing that there are 25 different frames per second. All the movement seems smooth. The reason for that is a phenomenon called visual inertia. We experience it all the time. That's why we can't see fast-moving or spinning objects clearly. Here's an example. An LED on a spinning disc. While the disc is spinning at a lower rate, we can see it clearly. But as we make the rate higher, the bright glow starts drawing a line. But there isn't any line in reality. It's just our eyes remember the LED's position. Alright, now let us check if the trick would work if I turn the LED on and off at a very high rate, and how it would affect the brightness. Look at the disc. Half of it is metal. Here are 2 contacts. I connect them to the LED on the breadboard and the battery. Now I rotate the disc. The current from the battery flows to the first contact via the cable, goes through the disc and proceeds to the second contact, then to the LED. The LED lights up. Now I rotate the disc again to its other part. This part doesn't conduct electricity, so the LED is off. Let us start spinning the disc slowly. See? The LED is blinking. Look at the graph below. One revolution of that electric motor happens in 1 second. For half a second the LED is on, and for another half a second it is off. Let's wind it up to 30,000 RPM. The LED is blinking, but we don't see its individual blinks. It looks like it is just on, with half the brightness. Let's make it dimmer. For that, we need a disc with metal covering only a quarter part of it, like that one. I install it and start spinning slowly. The LED is blinking, but the on state is shorter. Now it is only on for a quarter of a second and off for another 3 quarters. Wind up the disc. It looks like it is dimmer. Now install a disc that can conduct electricity with only an 1/8 part of it. Now spin it. The LED is barely glowing. By shortening the time the LED is on and increasing the time gap between the blinks, we can control the LED's brightness. This is called Pulse Width Modulation, or just PWM. Arduino can output such signal by itself. There is a timer inside its chip. It works in a similar manner to those spinning discs. It outputs power with short pulses according to the schedule. Connect the breadboard to Arduino. I had to swap the disc to change the LED's brightness, but in Arduino, a simple line of code is enough. 11 is the pin number where the LED is connected. What is 127? Let's pretend there is a disk inside Arduino divided in 255 sectors. The command states how many of the sectors conduct electricity, thus controlling how long the LED is on. 127 is approximately half of 255. The LED is half bright. This command makes it quarter bright. The amount of colored sectors is called duty cycle. I can't see the LED switching with my eyes, but have a device that outputs voltage shifting on a display. It is called an oscilloscope. If I touch the battery with the probes, the line jumps. And if I disconnect the battery, it goes down flat again. Connecting a lower voltage battery makes the line jump again, but not that high. As I said, the higher the voltage, the higher the line. Now let's create a program to control the LED's brightness. I want the LED to glow at about 1/3 of its total power. 255 divided by 3 is 85. Create a command to output power in pulses to pin 11, 85 times out of 255. Let's test. Connect the oscilloscope. The voltage jumps just like it did with those discs. Arduino outputs pulses, so the LED is 1/3 bright. With the command delay, we can put off the execution of the next command for 1/4 of a second. It will help us see the change in brightness. The LED will be on all the time. Now let's make it 2/3 bright. 255 by 2/3 is 170. Copy two previous commands, change 85 to 170 in analog write, and keep the delay. Paste two previous lines again, but now make the LED full bright. Change 170 to 255. The code is looped, so it will be executed over and over again. Let's see. With PWM, we can not only turn LEDs on, but also output more complex signals, like Batman's outline. We can see on the oscilloscope's display how Arduino changes the voltage. That is PWM changing over time. Doesn't resemble the Dark Knight? Right, we need to add something to the circuit. The already familiar resistor and capacitor. I'll tell you how it works in another episode. Now, instead of separate impulses, we have a picking Batman. There will be quite a lot of lessons with experiments and cool electronics in each of them. You can go wandering around some stores looking for particular components separately, or you can get them all at once on our website. There you can find everything we use for the lessons, like Arduino Uno, breadboards, resistors, transistors, diodes, buttons, electric motors, servos, potentiometers, wires, loudspeakers, displays, and much more. By the end of the course, you will be able to easily understand not only the basics, but even the advanced microelectronics. You can find the link to our website in the description below. You leave your versions in the comments on why the impulses turned into a smooth line, and I'm off to film the next episode. In the next episode, I will show you how to change voltage with the pencil, make Arduino measure a pin voltage, and tell you why resistors have a third leg.